finishing these notes via this video, the 4.9 notes. If you don't have it, grab it in the top shelf of the notes bin, and then fill out what you missed from Schoology. But the first thing we need to do is check our homework. Okay, so these are the answers to your homework right here. Okay, I have a little bit of work there as well. So feel free to freeze this and take a peek at those answers. And yeah, that's pretty much it. So again, looking at log base 2 of 59 for the people who didn't see it. If you have a new calculator, you can plug that in. If you have an older calculator, you can't directly plug it in. So you have to do log, oops, not there. You have to do log of 59 divided by log of 2. So you have to separate it like that. And that's how you get that answer. Okay, for the people with a newer calculator, alpha window, number 5, and then just punch it in like that. 2 and 59. All right, so that's the same answer. Okay. So again, check those answers, make sure they're right. If they're not right, ask a friend, see what you're doing wrong, and then try to figure it out. Okay. So to finish our notes today, we are right here. Okay, so a few sections ago, we graphed exponential function f of x equals 2 to the x. Graph the function below. All right, so you are able to use your calculator here, but really if you just plug in points, if I plug in 0, 2 to the 0 is 1. If I plug in 1, I get 2. If I plug in 2, I get 4. 3, I get 8. Negative 1, I get 1/2, because 2 to the negative first, I just flip it. 2 to the negative second, I flip it upside down, and then I square it, so 1 over 4. So my graph looks something like that. So these were the characteristics, some of the characteristics we talked about. So the domain is negative infinity to infinity. The range is 0 to infinity. The y-intercept is 1, and then I have a horizontal asymptote at y equals 0. Now, given this graph, I want to graph log base 2 of x with my graphing calculator. So the way to do that on my graphing calculator, I go to y equals, there we go. And then I'm going to type in log base 2 of x. Okay, so this is alpha window, number 5. And I'm doing log base 2 of x. Okay, again, on a older calculator, you're going to have to split it up. So you're going to have to do log of x divided by log of 2 using the change of base rule. Okay. But we'll just keep this one here for right now. So if I graph that, zoom standard, I get a graph that looks like this. I wanted you to fill in that table. Okay, so that table's already filled in, but if that table were not filled in, basically you would go to the second graph, which is the table. And then I would punch in whatever I think I would need to give me a whole number. So if I plug in a 2, I get a 1, so I can plot that one down, 2, 1. If I plug in a 1, I get 0, so that's a good one. If I plug in a 3, I get 1.585, so I don't want that one. I want to choose points that give me whole numbers, because eventually I'm going to have to graph these transformations. Okay. So that's basically what you do. Okay, if I plug in 0, I get undefined. If I plug in negative 1, I get undefined. Okay, so all my numbers are positive. And really I'm just kind of trying things out. So if I plug in a 4, if I plug in an 8, these are the numbers that I get. Okay, so you're filling out the table and graphing. All right, and what do you notice? Okay, this is exactly what we talked about the other day. This is negative 2, 1/4. This is 1/4, negative 2. This is 1, 2. This is 2, 1. These are all the flipped versions of this table, which makes this the inverse of that function. Okay, that's the whole reason why we talked about inverses in 4.8. 2 to the x, the inverse of 2 to the x is log base 2 of x. And the reason why I know that they're inverses is because these points are switched. Okay. So that's really the reason why we need the log function. We need to find the inverse of 2 to the x, and the inverse of exponentiation is logs. So these characteristics should make sense. All right, the domain and range are opposite. So in this case, the domain is 0 to infinity. The range is negative infinity to infinity. So these flip because of their inverses. Instead of a y-intercept, we have an x-intercept. Those flip. And instead of a horizontal asymptote, we have a vertical asymptote. Okay, and that's at x equals 0. All right, so as we talked about with exponential functions, the base of the log function can change. Okay, so remember this could be 3 to the x, 4 to the x, and all those types of things. The main idea stays the same. It's just that these points are going to be a little bit different. So it could be a little bit steeper or wider, but the main idea stays the same. Okay. So given this parent function, now we're going to the transformations yet again. All right, so in this case, we have log base 2 of x minus 1. So that's minus 1 inside the function, making that a horizontal shift. So I'm shifting everything right 1. Okay, even the asymptote. So because this is vertical, if I'm shifting all the points right 1, I also have to shift the asymptote right 1. All right, so all these points, I'm adding 1 to the x's to give me this graph right here. I have addition outside the function. Okay, there's no parentheses here, so that plus 2 is outside the function. Because that's outside the function, I would add this to my y, so that would be a vertical shift. Okay, because it's vertical, my vertical asymptote doesn't move, it just moves up, so it's in the same spot. All these y values I'm adding to. Okay, so 1/4 is now 0, 1/2 is 1, 1 is 2, and so on and so forth. And then one more. I have the same log base 2 of x, but I'm multiplying by 0.5 on the outside. So if it were on the inside, it would be right next to the x, but this is on the outside. Because it's on the outside, that's a vertical dilation or shrink by 1/2. So I'd multiply my y's by 0.5 or divide by 2. Okay, so if I divide my y's by 2, I end up with these points right here. Okay, so it's a vertical shrink. And that's the main idea for today. Okay, so your homework is to do the same thing, but with log base 3 of x. Okay, so using your graphing calculator, plot at least 5 whole points. So make sure the y values are whole numbers. So just kind of guess and check, try to find some that work. And then based on that parent function, you're graphing these two transformed functions. And then you also have another practice that the sub will give you. Okay, and that's about it. Okay, have a great day, people.